Yeah, let's begin. Yeah, my name is Georgios, in case you didn't know, or in case you didn't catch one of the other two presentations that I was here. And today's topic is going to be WebKit. It's going to be a little different from the rest of them. Yeah, I was back and forth between how I was going to do this because there was a part of me that wanted to be like super happy and bubbly and saying, "Whoa, things are moving! Yay! Woohoo! Yeah, accessible WebKit! Yay!" But yesterday night, during the thunderstorm, I had a change of heart, and I thought about doing a more grounded approach to this presentation, and see if I can get some feedback on the things that are happening here instead of just throwing them up to you and leaving. So yeah, WebKitGTK. Just for the sake of putting everyone on the same level, just going to do a quick introduction. WebKit is a project. WebKit has many ports. It's what they call it. One of the ports is WebKitGTK, which is essentially exposed as a GTK widget that you can embed on your application. You can put a GTK widget that is a web view on your program. There are other ports. Apple has a port, Windows has a port, PlayStation has a port. WP for embedded devices is another port, and WebKitGTK is one port. So it's important to say this. I feel like it's important to say this because it's a bunch of code that is platform agnostic, and then you have these ports containing the logic and the integration code for specific platforms. Most of what I'm going to be talking about here is WebKitGTK, but there is some overlap with the other Linux, the other Linux port, which is WebKit, WP WebKit. I don't think I need to introduce any one of you to GTK, hopefully. Oh no. But yeah, GTK4 specifically was a major breakthrough for the GNOME platform, for the bigger platform. And even though WebKit still has a GTK3 compatible API, we still offer a GTK3 widget for GTK3 applications to use. I think it is fair to say that most of the development is made primarily for GTK4 these days, for WebKitGTK, for GTK4. That's great. Yeah, this is, if you want to know more about the other Linux port, this is WebKit WP, and that's the link. It's going to be in my slides. After you can click that. So yeah, GTK4, fantastic toolkit, major breakthrough for the platform. In 2020, Emanuele rewrote the accessibility support for GTK4, like completely ditched away ATK, and now we have like everything in tree, and all the abstractions live inside GTK. And with that, we lost some features and some specific things that are, like, not gonna lie, super complicated, and like, if I was Emanuele, I wouldn't implement them in the first or second or even third iteration of any rewriting, to be honest. What's the current status of accessibility on WebKit? There's no green one. So I decided to split between GTK3 and GTK4. GTK3, the WebKit GTK3 support is pretty much exactly the same. It just uses ATK instead of GTK to do that. Accessibility of web views running under a Flatpak application is currently non-existent. They are a black hole for the screen reader, for example. As of last week, accessibility on non-flat-packed WebKit, but still sandboxed using bubble wrap, works. That means if you install Epiphany on your host system using your distro package, you will kinda have accessibility on the web pages that Epiphany is displaying. And, well, on the unsandboxed case, it is also in the same situation. Basically, as of last week, both bubble wrap and unsandboxed situations are equal. So really the major pain point right now is the Flatpak builds as a sandbox. And as I was saying, I decided to not go for a bubbly presentation about the new stuff, because I wanted to talk about the difficulties in making those two columns yellow, instead of talking about why none of them are green. So let's talk a little bit about the challenges of making a web browser accessible, a web engine accessible. So the first one, it is kind of specific to WebKitGTK and GTK4, out of process accessibility trees. So one very important security measure for, I think, all browsers these days they implement is to separate the beats of code that interact with the web page into a separate process. And they usually put that separate process in some sort of sandbox. I think Chromium uses Zygote for that. I think it's called Zygote. I don't think WebKit has anything with a fancy name, but it has a web process, a separate web process that handles the web page, loading the web page, rendering. I think it still uses the web process for rendering, but there are some talks about using a GPU process. And accessibility. So you open a web page on Epiphany, on GNOME Web, it's going to spawn a separate process to render that, and once the web process receives the web page, it builds an accessibility tree and puts on the accessibility bus. How do you bridge those two things? Because now we have an Epiphany process with one tree of accessible objects, and you have the web process with another tree of accessible objects. In the GTK3 days, we had ATK socket and ATK plug, which is what WebKit was using. In the GTK4 days, we didn't have anything to bridge those two worlds of accessible trees. This was solved by around February, and it's already available in GTK 4.14. We have a new object, GTK ATSPIX socket, I think, which does exactly that. You give it a buzz name and a buzz object, and it's going to bridge those two processes. So this one is fixed. Thanks for GTK developers for merging that and for being open to that approach. The second problem, the second challenge here, was debuzz filtering. This is specific to sandboxing. This is not specific. This does not happen when you're running WebKit unsandboxed. WebKit, when Flatpak opens the sandbox, for example, it runs XDG debuzz proxy, which of course is there to prevent applications from accessing debuzz services that they are not supposed to. The problem here is that the accessibility bus is very chattery. So one very common strategy to reduce the amount of traffic happening in the accessible bus, in the accessibility bus, is to only send updates about the accessible tree when there is, for example, Orca running on your computer. And to do that, you need to know that Orca is running on your computer. And to learn about that, you have to use dbuzz. You have to monitor some dbuzz events to figure that out. That's all very cool. Except that the dbuzz proxy was filtering those events out. So WebKitGTK was thinking that no screen reader was ever running, so it was not sending any updates. So you've got the same problem again. Nothing is available for ATSBI. And as of last week, this is fixed. We still need releases for all of those things, but the base problem is solved. And now I'm going to go for the big one, the problem that is the parent of all problems, the one tyrannic issue that cannot let us find happiness: Flatpak sub-sandboxing. And I really want to go deep into this one. I promised Michael a few weeks ago that I was going to document that. This is going to be my video documentation that I'm eventually going to make it into a blog post or something. So let's come with me. Let's go through the fantastic world of Flatpak. When you open GNOME shell and you find Epiphany, GNOME Web, you see that pretty icon and said, oh my God, I need to open this thing now. And you click that. GNOME shell is going to take the desktop file, and it's going to detect that it's a Flatpak app because, of course, you installed that from FlatHub. And it's going to run Flatpak run our GNOME Epiphany, right? We're cool to this point. And then Flatpak, it's going to install bubble wrap and make bubble wrap spawn XDG dbuzz proxy with some permissions. And then after spawning XDG dbuzz proxy, it's going to spawn Epiphany, the process. That's all very cool. That's how Flatpak works. That's how the sandboxing mechanism works. So this is phase one. We are almost running Epiphany now. The process has been launched. Pay attention to step number 4 here. Bubble wrap spawns XDG dbuzz proxy with permissions. Keep this on your mind. It's going to be an important aspect of this whole thing. Phase number 2, the web view. So Flatpak bubble wrap spawned Epiphany. The process Epiphany is going to connect to the dbuzz socket. I'm talking here specifically about the accessibility socket, but also the session socket. It's going to acquire a unique buzz name. It's going to show a pretty user interface for you. It's going to create the WebKit web view widget. And when it's presented the WebKit web view widget, it's going to detect that it's running in Flatpak. And we will use Flatpak spawn to spawn the web process. Flatpak spawn, it's going to call into the Flatpak portal. There is a portal for Flatpak. And it's going to do everything for us. It's OK. So here we are. Epiphany is almost completely showing a web page for you. Let's go to phase 3, the Flatpak portal. So the portal, of course, it runs outside of the sandbox. It does not belong to the Epiphany sandbox bubble. So the portal is going to receive from Epiphany like, hey, please run this process in a equally or stricter sandbox. The Flatpak portal is going to do exactly that, and it's going to go through the same thing that we talked about. It's going to spawn bubble wrap. Bubble wrap is going to spawn XDG dbuzz proxy with permissions for the sockets, and the web process. At last. All right, so we got a web process now. Oh my God, 10 minutes. We got a web process. It took me 10 minutes to get to the web process. We're going to do that. We're going to make it. The web process is going to do all of that again. It's going to connect to the accessibility bus. It's also got a unique dbuzz name. It's going to start doing web processing stuff. It's going to download the web page. It's going to figure things out. And it's going to tell Epiphany, hey, I'm ready. I think you can send whatever data you want to me. And then here we come. Here we are. GNOME Web is going to receive that message. It's going to say, oh, OK, cool, the web process is ready. I can tell my GTK widget that that is the web process. And I'm going to do that by calling this specific accessibility API or accessibility method. Or A11i at SPI sock embedded. That's what ATSPI expects us to do when we're dealing with out-of-process accessibility trees. And it's going to fail. So the bridge is not going to be bridging those two accessibility trees, and we got a black hole accessibility void for screen readers. Why does it fail? Can anybody guess that? Does anybody have any idea? A shred of an idea. I see a little hand raising over there. Say that again? The unique name is not fake. It's very legit. Yeah, XGTBus proxy is telling, no, you're not gonna call that. You are refused to call that. That's a difficult thing, right? So, remember on phase 1, when we spawned the bubble wrap, when bubble wrap spawned XGTBus proxy with a set of permissions, turns out this set of permissions did not contain you can talk to the web process that still doesn't exist. In XGTBus proxy, you cannot change the list of permissions at runtime. You spawn it, and it's fixed. It's done. The Epiphany dbus proxy was not set to talk to the web process dbus proxy. It is not fixed. It is fully not fixed. And this is where we are right now. The other challenge, and this is a challenge that is going to come after we fix the current one. The contents of the accessible tree are not exactly what Orca expects, so it cannot read properly, so we need to figure that out. There's a bunch of tickets filed about it. But right now, there's not even what to fix because we cannot even see the accessible tree. Orca cannot even see the accessible tree. That's also not fixed. The roadmap is quite simple. Once we got those two things out of the way, we're going to get an accessible WebKit GTK, and GNOME Web's going to be probably the first fully sandboxed and Flatpak friendly, fully accessible browser in existence. Yeah. Thank you for listening to me. I think we have 5 minutes. I don't know if you guys have questions. Folks have questions, sorry.
Two quick questions. One is this in any way, is any of this relating to the work that Matthew Campbell was doing on Newton? And two, any timeline, you just close with a really happy, like this is going to be the first fully accessible. Is there any timeline, GNOME 47, 48, 72, no timeline, I don't know.
So this relates in some way to Matt's work, but not fully, because I think Matt's work is going to have the same problem that we have here. You cannot open an accessible bus to the web. Maybe. It depends on how it is designed. If it requires communicating with the web process through the accessibility daemon, then it's going to fail in the same way. If it doesn't require that, then it's going to work. And the second question is if there's a timeline for this to be fixed. Once somebody, probably me, but if somebody else does that, I'm going to be super happy to. I'll be happy to implement. When we figured out how to fix this on a design level, on a theoretical level, then somebody just has to implement, and I'll be happy to do that. I'm being paid to do that, so I'll be the first one to do that. So yeah, sorry, probably no time. The timeline is after figuring it out. Before figuring it out, it's not going to happen. I think we have one other one.
Hello? Could you hear me? Hello?
Yes.
So I think what Matt was suggesting was push API, right? So if all the trees and subtrees are pushed up out of the sandbox, then theoretically they could be connected together outside of the sandbox, then you wouldn't have that issue of crossing over or using the socket at all. That's one thought. And then my question was, why do the sub-processes need to be in their own sandboxes? Why can't you have the entire WebKit process tree in the single sandbox?
Because that makes Michael very unhappy.
Okay.
I mean, it is, I think most browsers in Flatpak land right now, in FlatHub, they either disable sandboxing or they do a poor version of that, a downgraded version of that. And it's like, I joked about Michael being unhappy with this, but I think there's a point to be made about fully isolating what is probably the most complicated engine on your computer so that it doesn't access stuff. Like, it is a very tight hardening security boundary. It's going to be hard to break that.
We have time for one more.
One more question.
So you said that you were focusing on making those dots yellow. What will it take to make them green?
Can you repeat the question?
How do we make those dots green?
How do we make those?
The dots, like in your chart, you were talking about going from red to yellow.
We just have to fix those two things in the roadmap. It's easy as that. Once we do that, everything. Oh, am I in the right? Yeah. Once this is fixed, everything is going to be green. We're going to be in Greenland. Fantastic. Maybe we have remote questions on the chat? No. No?
All right. Thank you so much for George's on the great talk.
Thank you.
Next up, we have a 15-minute coffee break, actually in the tavern, which will be unique. Okay. And